Hello, hello. Am I audible?
Yes, sir.
Okay, so since there is no participant till now, so I haven't started session. So without participant, I could not start. So yeah, so let, since there is only one participant, so I should start because the audience is decreasing exponentially. So I should start. So have you covered this week uh, uh, material like whatever have been taught in this week, like this? Otherwise, I will recall, or otherwise, I will directly go to
I
problem.
have watched the lectures, but
Okay, so you have.
the last week and this week's lectures were a bit different. The generating functions, I'm not super, comfortable with it yet.
Okay, so let's recall the theory, then go to problem, right? That's fine, right?
Uh, let's not just do the theory, but when doing a problem, just recall certain tricky parts. That would be better, I think.
Yes, the only like the main use of the theory is what I feel on the problems is of the product rule where we are using exponential generating function, where we are using ordinary, where we need to use ordinary generating function, where we and like this basically product rule and all this. This is the main thing. So let me just quickly recall what is generating function, where we will
Okay.
use ordinary one, where we will use
Okay.
exponential one, then go to the problem.
Okay.
I guess this will be the best case, I feel. So let's start. Share the screen. Start now. So mm, uh, recall. So this is just a quick recall. So what is a generating function? Generating function. So just quickly recall. So this week theory is quite important. So it may get 1 or 2 pages to recall the theory. So generating function is a representation of an infinite sequence and sequence of numbers as a coefficient of a formal power series. So generating function is a representation of sequence an n bigger than equals 0 as a coefficient of formal power series. Then we are interested in its closed form. Basically, we want to find some closed form for this power series expansion in all the problems. So mostly we are interested in the its closed form. Then comes the ordinary generate. Then we till now we have studied two kind of generating function. Which first one is ordinary generating function, and second one is uh, exponential generating function. Exponential generating function. Okay, so what is an ordinary generating function? Given a sequence, okay, let me write here only. So what is an ordinary generating function? Given a sequence an of natural number of any numbers and greater than equals 0. So corresponding to this sequence, you associate a formal power series, which is basically summation an x to the power n bigger than equals 0. And what is this exponential generating function corresponding to the sequence n bigger than equals 0? You associate a formal power series an x to the power n by n factorial. So why this call exponential? Because if you put the all an equals to 1, this is just an exponential expansion. And why we introduce this? Basically, I guess instructor explained this in a course because it may happen the series summation an does not converge. So we are interested. So we need to do this, like he explained by giving some examples in his lecture. So let's go ahead. This is a ordinary and expand. So main use of these things is how, what is the combinatorial? So we can basically multiply and all these things. So what is the thing? So suppose, suppose we have two power series. Suppose you have two formal power series a n x to the power n and b m x to the power n greater than equals 0 and n greater than equals 0. We have two power series. We want to multiply them. The multiplication is clear. An x to the power n into bm x to the power n is equals to summation an bm x to the power m plus n, n greater than equals 0, n greater than equals 0. Right? So this is going to happen. This is simple multiplication. But what is the combinatorial interpretation of this? This is the useful for problem. So what is the combinatorial meaning of the product of OGF? So this is the important for doing problem. Combinatorial meaning of product of OGF, ordinary generating function. So suppose an is equals to, let's say an denotes the number of ways of giving combinatorial structure A on the set n, number of ways of giving some structure, combinatorial structure A on the n element set, and Bn denotes the number of ways of giving combinatorial structure B on the set n, and Cn denotes total number of ways to first build a structure of type A on S, which is some subset, and okay, basically these are not subsets; these are intervals basically in this case, and in exponential case that are subsets. So this is the difference in the product. Total number of ways to first build a structure of type A on S equals to 1, 2 up to I, and type B structure on T equals to I plus 1 to up to n, right? For each I, 0 less than I less than equals n. So if corresponding to an, we associate a power series corresponding to an, we associate a power series which is ax summation an x to the power n. Bn, we associate a power series bx which is summation bn xn, and corresponding to cn, we associate a power series cx. Then cx is equals to ax into bx. Let's do a problem related to this. Then it will be more clear. Hmm, Let me write the problem. We'll write the product rule, composition rule for each one and do problem related to that. That is better, I guess. So yeah. So question. So what is this given? All n military squadron squadron stand in line. Okay, the officer splits the line splits the line. I guess this one for a beginning problem, this will be harder. So let's do some simple problem first, I guess. Hmm, let's do this only. The officer splits the line at several places forming smaller non-empty units. Then then he choose a possibly empty subset of the newly formed units for night duty. In how many ways can this be done? Yes, yes, this is the question. So how to do this? Give me ideas. Have you understood the problem? This is saying that there is a N military squadron standing in a line. The officer splits the line at several places, forming smaller units. Then he chooses a possibly empty subset of the newly formed units for night duty. In how many ways this can be done?
Uh,
Yes, yes,
so uh, in military means n people, right?
yes,
Uh, so here we want to first the splitting represents a structure, and then choosing the night duty represents the another structure.
yes.
So, so the first one say corresponds to a corresponds to A. Then for each A we have yeah, say is the counting sequence B for creating the night duty structure.
So, oh yeah, here composition will be used, right? Mm,
Yes.
not
So A of
multiplication.
B of X.
Yes, B of A of X you want to say, right?
Yes. Yeah.
But how you will find the coefficients? AN and BN. So basically, idea is what he is saying. So suppose we have these N military peoples sitting on a line. These are N peoples. So all N military line, the officer splits the line at several places. So this is some splitting. This is some splitting. Now, what he's saying, then he choose a possibly empty subset of the newly formed units. Okay. First, we are forming the units, and then he, okay, option, okay. Then he choose a possibly empty subset of the newly formed unit for night duty. Okay, then he choosing. Okay, so here composition rule will be used. So, do you know composition of ordinary generating functions, or should I need to recall that?
Yes, I have watched it, but when you do it, I might have some questions about it.
Okay, so same thing basically. An is number of ways to give a combinatorial structure on A. Bn is a number of ways to give combinatorial structure on B. Then and Cn is number of ways to split n to non-empty intervals and build structure a a structure on each interval and build a b structure on the set of intervals. Where there the set of elements will be there the elements will be the intervals where we are putting b structure. Then in this c of x is b of a of x. So this is the case here. So okay. So what is ax in this case?
So it is basically so from k from 1 to n choose k summation
Summation
k from 1 to n, and then you n choose k.
k equals to 1 to n and choose k. So you are choosing k subset, right?
Has so for each possibility,
But this is not correct because this is interval. You are choosing as an interval, not as a subset, right?
okay. So you have you can okay. So can we think of this as an inserting bars
Yes,
in
yes,
between?
yes, 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 yes. You can think in that. Okay. So, so let's write. So ax will be something function corresponds to structure applied on each interval, and then bx will be function structure that need to applied on set of interval, right? This is the thing. This is how we will use this composition word. So function corres- how I should write? Ex will be function corresponding the structure applied on each interval on each interval, and bx will be function corresponds structure applied on set of intervals. So what is the function bx in this case? Possibly empty subset of the newly formed interval for night duty. So choosing, okay, then he chooses possibly empty subset of, first we are forming subsets and then choosing a subset, then he choose a possibly empty subset of the newly formed units for night duty. Okay,
So that's all possible subset 2 to the power whatever the amount of people there are. He
okay,
chooses a subset, right?
yes. So then, okay, so our bx will be look like this. At least bx is clear. Bx will be look like summation n equals to 0, n greater than equals to 0, 2 to the power n, x to the power n, right?
2 to the power n is yes, yes, for
Yes, yes. for each n elements that we have 2 to the power n, right?
Right.
So what is ax? So ax, how we will find ax? So let's think. I'm also thinking.
So
Yeah, you are saying something?
we can think of this as putting
Summation
a
x1 plus x2 plus xk equals to n, something like that we can think, right? Then ax, how will we reply? What is condition on ax? So officer splits the line at intervals at several places, forming smaller units. So it can be okay. So
I
smaller
think it will
units.
be n minus 1 factorial,
Why
because
n minus one?
so see, scroll a bit down to the line you have drawn, the interval.
Yes.
So
Yes.
think about a bar. So
Okay.
if you have one bar, you
Okay.
if you put it to the left of one that you have
Hmm.
written, you have only one
Hmm.
choice. That means you have only one interval. You choose the whole entire line, right?
Okay.
So you
Hmm.
then consider the next step. So you put it between 1 and 2. Then
Huh.
you have chosen one guy and the other rest of n minus 1 guys. So if you
Okay.
put two bars, you have one in the front, and then other choice is for the remaining n minus 2 positions. So that
Okay.
way, the more bars you keep adding, and the number of
Hmm.
the
Interval
set
will be
intervals
increased.
increases, and it's goes one less. You keep having one less position for each of the bars you choose.
So that from that, how you are concluding?
So uh, for if you keep on doing this, ultimately you will have one all sets intervals, so the first one will be only one, then you have chosen only second. If you put all the bars inside, and you can
Okay,
put
you are
only
saying
n
that okay,
minus.
if you are putting no bar, then you have only one interval. If you are putting one bar, then you have two interval. In this way, you are saying.
If you try to split it into intervals of size 1,
Okay,
then you will.
okay, what you are saying. So you are saying this thing. If there is no bar at all, then you have only one interval. If you are saying you have put in one bar, then you put one bar here, then you have two intervals, right? Then you are saying
Yes.
you put third bar somewhere here, then it will again split it into two ones. So what is the conclusion? What you want to say?
So when you have put one bar,
Huh?
you can choose the n minus
You are saying your
one
power
positions
series will
in
be look.
between.
Yes.
And
Huh?
then if you choose two bars, then you have
Huh?
one position occupied, and then you can choose n minus 3 positions, and so on.
Yes. 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 So you are saying your power series will be look like one plus if you are putting one bar, then 2x plus if you are putting three bars, then if you are putting two bars, then it will be how many intervals? Three intervals. Are you saying this? If you are putting no bar, then you have one interval. If you are putting one bar, then you have two intervals. If you are putting two bar, then you have three intervals. In this way, you are saying
No, if I put say 1 bars, I will have n minus 1 intervals, not 2 intervals.
if you are putting n bars, then you have how many intervals?
If I put n bars, then I'll have exactly you can put n bars actually. You can put at most n minus 1 bars.
Yes.
So you will have only you will have distinct n intervals,
And yes.
each of containing one guy.
Yes. So we have n intervals now when you are putting n bar. So if you are putting no bar, then you have one interval. If you are putting one bar, then two interval, then two bar, three interval. So this should be power series, na?
See, because of the choice, the interval changes. So if you put one bar, it's not that you will only have two intervals.
Ah, yes, yes, we have more intervals. I got your idea. So how many interval we have? Okay, we need to determine its. So it is this have n minus one, right?
You
N
have n
minus one
minus
choice.
one choices to put the first if you have only one bar.
Yes. If you have two bar, then we have how many choices?
Well, you
For
first
first one,
choose one of the positions in minus one, then in minus you have remaining in minus two positions to choose from. In minus one times in
okay,
minus two.
okay. So let's write. What you are saying? Okay. What is the coefficient? So summation a n x to the power n, where a n equals what you are saying? Let's
Uh,
start with a naught. What is a naught? A
in
naught is
so there's only one choice, one
a naught is one choice because okay,
or the whole
right?
thing.
When yes.
So you
What
put
is a one?
so
One bar
then
only. Then
it will be uh, well, you choose n minus one position, so it will be n minus one.
we choose n minus one positions, right? Yes. We have n minus one choices. What is a two?
Then you have chosen one of the n minus one times n minus two. So n minus one
Yes.
times n minus two.
Similarly, this will go on, right?
Yes.
A3 will be n minus 1 into n minus 2 into n minus
So
3.
a n will become n minus one factorial, I think.
An will be n minus 1, n minus 2, n minus 3, so on, so on. N minus n,
So
basically.
until it reaches n, so it becomes
An
n
minus
minus
1.
one.
Yes. Last will be a, because we have only n minus 1, we can put only n
Yes,
minus
yes,
1
yes.
bars. Yes. So that will be what?
N minus one factorial, right?
Right. Yes. So this is the thing. Now we can use this composition rule. So Cx is equals to b of ax. So b of uh, x, b of 1 plus n minus 1, x plus n minus 1 into n minus 2, x square, uh, plus so on, so on, so on. This is summation. Then what is bx? Bx is 2 to the power n, x to the power n. Okay, so we have to find some closed form for this ax now. So what is the closed form for this ax? 1 plus n minus 1 x, n minus. What is the closed form for this x?
Do we not already have a n minus
Hmm?
one? Do we not already have a n minus one as n minus one factorial?
Yes, we have, but what is the closed form?
Okay.
This is the summation running over all n greater
Summation
than
running
0.
over
No?
all of it. Yes, yes.
So we have to find the closed form for this. So ax is of the form summation n bigger than equals 0. Hmm. We are getting each coefficient in each coefficient a polynomial uh, n greater than 0. Okay, let's try. Ax is of this form. Uh, This is a node. This how to write this one. 1 when n is equals to 0, then it is 1. When n is equals to 1, this is a1. This is n minus 1 is n minus 1 into n minus 2 square n minus 1 into what is the closed form for this one? So we can do one thing. We can take 1 plus nx plus n square x square plus n cube x cube. One this thing. Then what remaining? Then minus x we have to some rearrange minus 2 and
So it
minus
is
n.
something like this, if I think, if I'm thinking correctly. So the coefficients, in terms of the coefficients, it's like product over so product over n factorial by n minus k factorial, where k ranges n minus 1 factorial by n minus k factorial, where k ranges from 2 to n.
Okay. So you are saying this will be of this form. Ax is of form what?
Product
Product
k is equal to
k is equals
running
to
from k is equal to 2
2
to
and
n minus 1 factorial
n minus 1 factorial
by divided
by
by n minus k factorial.
minus k factorial. Okay. So x to the power k, no?
Yes.
And here summation going on from n to n greater than 0, right?
Oh, just add 1, I think. N minus 1, so 2 for 2, n minus 2. So it becomes n minus 3. So that must be n minus k minus 1. So in the
So for
denominator, that must be n minus k minus 1.
so what for one and coefficient when coefficient is 1 and when x, so you want to add 1 plus x here again? Or you should start your k with 1. There is something we need to modify. So when coefficient
Or
when power
when
of
it
x is
is 1, when it is 2, n minus 2, n minus, okay, n minus 1, 2.
I should make it x power k plus 1, then it is working, because when you put k equals to 2, then you will get n minus 1 factorial by n minus k. So n minus k will be n minus 2.
So yes, k, if k starts from 1, then we get the first coefficient, right? So you have to start k from 1.
So if you are putting k equals 1, then n minus 1. So that will be
It cancels out and becomes okay. For then, yes. No, you have to
so
have the plus 1. So x to the power 0, no? So if for x to the power 0 we have 1, so n minus 1 factorial by n minus 1 factorial should cancel out to 1. So now if you have k is equal to 1, then that means x is equal to x, the second term n minus 1 times x, that
Hmm.
doesn't match, right? So because
Hmm.
you have x, so k plus 1 was correct before, right?
If you put k plus 1, then
Then we have for k is equal to actually that
so
must
x,
k minus 1 actually, no? The x
yes,
to the
we
power
have to
k
put k
minus 1.
minus 1. Yes, we have to put k minus 1. That is correct. I guess now it will work. So when we are putting k equals to 1, so it will be one of the coefficient of x to the power 0. If we are putting k equals to 2, then this is n minus 1 factorial by n minus 2 factorial, which is n minus 1x. Now it is fine. Now it is working. Yes. But still it is not closed form. Here summation is running from 0.
Yes.
So, okay, let's think about this problem at last. Do some other
Okay.
problems,
Okay.
right? Because this is quite tricky one. Okay. So let's do some simple problem first and then we'll come back to this. So question. 5 unbiased standard 6-faced dice, each level 1, 2, 3, 4, 5, 6 in its faces are rolled. Find the generating function that counts the number of ways the each of the possible sums 5, 6, so on up to 30 occurs. So this is a simple one. So 5 unbiased standard 6-faced dice labeled 1, 2, 3, 4, 5, 6 in its faces are rolled. Find the generating function that counts the number of ways that each of the possible sum 5 to 6 to 30 occurs. Can you answer it? This is simple one. If you are if you are rolling a dice, then what are the possible outcomes? Either it can come 1, or it can come 2, it can come 3, it can come 4, it can come 5, it can come 6, right? Similarly on other ones. So you are tossing 5 ones, rolling 5 dice. So you can just and these are each one is a independent. Each decision is independent of the previous one. So what you can do?
So I have a question here. So
Yes.
in the generating function,
Uh,
is it required that the number of the numbers of the sum are directly identifiable? Say for I want to check what is the number of the possible sums for 8. So does that correspond to the x to the power 8 coefficient?
what you are saying? Can you say again?
Is it necessary that in generating function, say
Hmm.
if I check the coefficient for x to the power 8, I get the
Okay.
sum of possible rolls that add up to 8.
Yes.
Does its coefficient correspond to the sum
Yes.
that add up
Huh.
to 8, right?
Yes. Yes. Coefficient of x to the power 8 in a generating function will give the right ruling whose sum is up to 8, whose sum is 8 basically.
Sum is exactly 8 or up to 8?
Exactly 8.
Exactly. Okay.
Yes. So let me give you some hint. So x cubed plus x to the power 4 plus x to the power 5
So up
plus
to
x to
4,
the
it will be 0, all of the coefficients.
no, why it will be 0?
So you can't have two dice give uh, 4, no? Oh no, sorry,
Why
I'm
you
wrong. You can't give two dice less than 2. So only the first x to the power 1 will be 0, no?
x to the power 1, why it will be 0? We have 5 dices, right? Even in if each dice get 1, there is no problem because we will get a number 5 whose sum is 5.
You are counting the sum. So
Yes.
if x to the power is not in the sum, x to the power whatever a1, so 1 is not present in the sum.
1 is not present in the sum. One cannot occur as a sum, right? Because
Yes. So its
each
coefficient should be 0.
I haven't created generating function till now. I'm just giving you some hint. This fx is not generating function. I'm not saying this is generating function.
No, I'm just asking in the generating function, should it be the case?
In the generating function, you are saying x to the power 1 will not occur.
Yes, it will basically have coefficient
Yes, it
0.
will not occur. It will not occur. That is
Okay.
correct.
Okay. Yeah, yes,
Because
that's so.
yes. So if you are this is for single when you are rolling a single dice, then it can have it can we can get 1, we can get 2, we can get 3, we can get 4, we can get 5, we can get 6, right? This is the only possible one. Similarly,
Yes.
when you are rolling second one, the same thing can happen. So you can just rule the product, use the product rule, right?
Yeah.
Generating function will be ex will be for first one fx, for second one fx, for 5 times. So gx will be, so
Oh,
you can compute it.
yes, I see. So the minimum power will automatically get raised to 5.
Yes, 5 times. So just you can do the computation and this will give the required thing. Is it clear?
Yes.
Okay. Next problem. This is also good. Not so easy, but not so tough. A kid went to shopkeeper, asked for a change of Rs 100 in denominations of 1 to 5 and 10. Find the generating function fx fx such that coefficient of x to the power 100 in fx is the number of ways in which the shopkeeper can return in which the shopkeeper can return the change. Yes, this is the problem. A kid went to a shopkeeper to ask for a change of Rs 100 in denomination of 1 to 5 and 100 and 10. Find the generating function fx such that coefficient of x to the power 100 in fx is the number of ways in which the shopkeeper can return the change. Can you tell me?
Sure.
Hmm? You are saying something?
I'm not sure yet about.
Okay. So, right. So, we want to express 100 as a sum of 1 to 5 and 10. So, we are asking how many ways it is possible, right? So, this thing. So, let's say f1x, f1x, if we are giving in terms of 1, so what can happen? It can happen that we don't give any like denomination of 1 rupees. So, in this case, 1 dot x to the power 0. If we are giving uh, one denomination of 1 rupees, then x to the power 1. If we are giving two denomination x to the power 2, so on, so on, so on. Similarly,
Sir,
for 2 rupees, huh?
so f of 1 is f1 of x is basically for the 1 rupee, right? Change.
Yes, yes, for
So
1
if
rupee change.
so for 1 rupee, is it not that we can give anything in only one way?
Anything and only given one way
Because
means
if you have
what you
only
are
one choice, you have to whole thing in 1 rupees.
whole thing in. But
So if you
that
have,
is okay. You are saying if you have 10 rupees, then you can give 10 note of 1 rupees. That's what you are saying, right?
that is the only option, right?
But yes, but it can happen that like you are choosing only one note of 1 rupee. Like when you are multiplying this thing, na? Okay, let me explain it. So when you are suppose you are taking one note of 1 rupee, then from power series from this 2 rupees you are taking some note of 2k notes of 2 rupees. This will give their product will give all when their product will be 100, then it matters how 1 rupee is contributing. You are not giving all 10 notes of 1 rupees, right? Are you getting or not?
Can you repeat?
So suppose you have 100 notes of 1 rupees. So you are choosing L notes of 1 rupees, M notes of 2 M notes of 2 rupees, uh, 3 what else, 5 M notes of this 5 rupees, and so their total sum will be, when that sum will be 100, so only these L notes are contributing and not all 100 notes are there. So you are asking denomination of 100 in terms of 1, 2, 5, and 10. So I am saying, okay, suppose it can have one note, it can have two note of 1 rupees, it can have any note of 1 rupees. So that's why I'm writing in this way.
So what does f1 of x exactly represent?
number of notes of 1 rupees.
And
Please do
their
for
sum can be what? Anything.
anything in up to 100.
Okay, so we are looking at so say for so when we check the answer in terms of counting sequence, we just look at the power. So say you have 10, so x to the power 10 has coefficient 1, so only one way to give. Am I right?
Yes. Yes.
Oh, okay.
So similarly, f2x, either it can happen that there is no note of 2 rupees, there is one note of 2 rupees, there are two notes of 2 rupees, there are three notes of 2 rupees, and so on, so on, so on. Similarly, for f5 and f10, it can happen that there is no note of 5 rupees, there is one note of 5 rupees, there is two notes of 5 rupees, and so on, so on. So now we can just use the product rule. So that will be f1 dot f2 dot f3 dot sorry, f1 dot f2 dot f5 dot f10. So first one is, we know what is this thing. This is basically 1 upon 1 minus x. This is what? 1 upon 1 minus x to the power 2k. 1 upon 1 minus x to the power what? What I should write? K, sorry. X to the power k, na? Am I correct? Or 2k? 1 plus x 1 plus x 1 minus x square, right? This is the, and this is minus x to the power 5, and this is clear now. How I am writing this expression, this is clear now or not?
So yes, I think it's because you have so x1 every term has a 5 power, so that's
Yes,
why you are writing 1 by 1 minus 6.
yes, yes, yes. This is 1 plus x. This is by this geometric sum, geometric series sum, geometric progression sum. What is the sum of this one? Basically, r is x to the power 5. So basically, 1 upon 1 minus r is the sum of a geometric series, right?
Yes.
Yes, by that definition. So what is this thing? You can just compute. So this is 1 upon 1 minus x into 1 upon 1 minus x square, 1 upon 1 minus x to the power 5, 1 upon 1 minus x to the power 10. So there is no need of writing in this way. Yeah, you can
Is it
just compute.
necessary in giving when actually giving answers in some say some
Here
related
the
thing?
closed form is not, here the closed form is not necessary, right? Because you just need the coefficient of x to the power 100. So what are the possible ways? Maybe from here you can choose no note of 1 rupees, here you two note, one note of 2 rupees, here is some note of 5 rupees, and remaining note of 10 rupees. So in this way you can do, like here this closed form is not necessary. You can just see all the possible combinations coming from here. So the coefficient of x to the power 100 in this expression fx would express number of ways of number of ways to express 100 as a sum of 1, 2, 5, and 10, right? Because if you are choosing some note of 1 rupees from here, some note of 2 rupees from here, that will exactly expressing 100 as a sum of 1 rupees, 2 rupees, and 5 rupees and 10 rupees notes. right? So this is
Yes,
the required thing. So have you got any doubt? Now you can ask me.
yes, I've got it.
Sure or not? Like it seems like you haven't understood some part. So if not, you can ask me at this point.
No, I think I'm okay with it.
Okay, let's go ahead. Question. So let n be positive integer. Determine the exponential generating function for the sequence of numbers for the sequence of numbers np0, np1, npn, where npk denotes the number of k permutations of an element set. So what is the problem? Problem is n be a positive integer. So where we have to determine the exponential generating function for these numbers. So this is the sequence of numbers. We have to determine the exponential generating function for this. So have you understood the problem? What he's asking? What I should do? How the generating exponential generating function will be look like?
So, uh, I mean, can we directly apply the formula for permutations? So the n factorial by n minus k factorial. So and then the k is the power of x to the power k.
Hmm. So
So f of x is equal to say 1 plus
1 plus
uh, n factorial by
n factorial by n factorial by what? What is np1?
hello.
Yeah,
Am I
can you
audible?
hear me?
Hello.
Yes, you are audible.
Yes, n factorial by n minus k factorial. N minus actually this will be 1 factorial, yes. Then x to the power of this then so on. So basically,
Hmm.
1 will be replaced by the next term's power.
2 factorial x square by 2 factorial. So what will happen? N factorial by n minus n factorial x to the power n by n factorial. So this is the last term. So what will this?
So in the closed form, the coefficient is exactly n factorial by n minus k factorial for x to the power k.
right?
Yes, yes. So, but now
But
haven't we gone back to ordinary generating functions?
haven't we got back to ordinary generating function? No, we
Because
are using definition of exponential generating function, right?
shouldn't we keep it in that form?
No, why? Determine the exponential generating function. He is saying determine the exponential generating function. I am determining because exponential generating function will be of the form an x to the power n by n factorial. I am
Yes.
taking this n factorial with this an. So what is the problem?
Okay, okay.
If I just choose an x to the power n, then it is ordinary generating function. But I am taking n factorial as well, right? A permutation of an element set. Permutations of. So what is this expression?
This is 2 to the power n.
This is
2 to the power n.
y.
So this is sum of all subsets.
N choose I is summation n choose I is 2 to the power n, but here this is n, n choose I x to the power k. So why it is 2 to the power n?
N choose
When
I.
x is equals to 1, then it is 2 to the power n. When x is 1, then this expression will be of the form k equals to 0 to n, where n choose either. Then it is 2 to the power n, that I agree. But why this is 2 to the power n?
Can you repeat the question?
What is this expression denoting? I am saying. What is this thing?
The coefficient is the sum of subsets.
Okay. So what is this? Is this something well known to you?
Sorry, I'm not in terms of uh, oh, what I- what sh- in what is the derivation in terms of you are asking?
I'm asking this thing only. This just use the binomial theorem. What is
Okay.
the
Oh, yes,
more?
yes, yes.
Yes. Okay. So next problem. This might be interesting and tough as well. We have n distinct cards. We want to split their set into non-empty subset so that each of them contains an even number of cards. Then we want to order the cards within each subgroup. Finally, we want to order the subgroup into line a line find an explicit formula for the number of which gn we can do this. So this is the problem. We have n distinct cards. We want to split their set into non-empty subsets so that each of them contain an even number of cards. Okay, so then we want to order the cards within each subgroup. Okay, finally we want to order the subgroup into a line. Okay, this subgroup into a line. Find an explicit formula for the number of ways we can do this. Okay, so what this problem seems to you?
In the
What kind of generating function we need to use, and what is then what we need to use? So what is the idea?
so we need to use product of generating functions here.
We need to use product of generating function.
Yes.
What are two independent structures here?
Yes.
For product, we need to have two independent structure. Then we are saying what is the possibility for C giving some part A structure and its complement or remaining one interval accordingly, whether we are in exponential or ordinary case, A and B structure as well. So what is A and B here? So that they are independent. Product rule is clear to you, na? I explained initially.
Yes.
Or should I need to recall? In product rule, you have an and bn number of ways giving structure A and structure B. Then you are asking, suppose, then you are asking first choosing, and if you are in ordinary case, then choosing an interval and giving this interval structure A and the interval, then the remaining interval structure B. Then the remaining interval structure B. So then Cx is a product of Ax and Bx. But in this case, how you are saying this is happening? If you are in so how you are saying what is the Ax and Bx in this case? So read the problem again. This is saying that we have n distinct cards. We want to split these their set into non-empty subsets, right? So we have n cards. We are distributing them into non-empty subsets so that each of them contains an even number of cards. So okay, we are splitting the n distinct cards such that in the subgroup such that each subgroup have even number of even number of cards. Then we want to order these cards within each subgroup. Okay, then we are doing in each subgroup we are ordering the cards. Then we are arranging that each subgroup into a line. So what is this seems to you? First we are working within the set, then we are working on the set containing these sets basically. What is this thing?
Composition. So
This is composition, na? So what
composition.
kind of composition? Exponential composition or ordinary composition? What kind of generating function we need to use? Whether whether we need to use interval here or we need to use subset here. In case of ordinary, we use intervals, right? In case of
Yes, we have
exponential, we use
subset.
subsets. Yes. So what
So
is
it
we
will
need
be
to use here?
so exponential.
Yes. So now we are in correct line. We need to use exponentially generating function and composition. Okay. So let me write and you will tell me. So solution. So the problem is asking for the partition of a set, ordering on each part and then ordering the parts, right? This is the what the problem is saying to us. Okay. So let an be the number of ways to order even number of cards. Because okay, so this thing we want to split their set into non-empty subsets so that each of them contain an even number. Each of the subset should contain even number. So that means the n should be even, right? Because we are distributing n cards to even sets basically. Each set should contain even number. So a and b the number of ways to order even number of cards, right?
That
What will be the ways?
this is the second part, no?
This is
Uh, this is the second part after we have chosen the even subset ordering.
yes, yes, yes. First we need to choose even subsets.
Yes.
Then we are doing this. Sorry, I shouldn't write this, right? First I should do the first case.
This is the second part when you have the subgroup. In the subgroup, you are ordering the cards.
Yes. Hmm. Yes. First I should do what? I should do what first?
So, just I don't remember it exactly, but was it that when you have even n, if you want to have only even, if you want to count only the even subsets, it's to the power n minus 1.
Hmm. Can you say again?
So for even n,
Yes.
so if you want to only count the even subsets, even cardinality subsets, was
Hmm.
it that it was 2 to the power n minus 1? Maybe I'm remembering it wrong.
When you are want to count even cardinality set, it is 2 to the power n minus 1. We have to, okay. So this will take some effort. I don't remember exactly. What is this? Is to order even number of parts. Okay, so first I should choose so that each of them containing even number of cards. Them contain even number of cards. This is both are same thing, na? First I choose n subsets and then arrange within each subsets, or whether I first arrange them and then choose a subset. And these both thing are same because I am already getting ordering, right?
What are you saying? Please, can you repeat?
Okay. First I am ordering the subsets, ordering the cards basically, n
Okay.
cards. Then I will choose the subset.
If you choose subset, then you destroy the order.
Yes. Both are same thing I'm saying.
No, I'm saying that when you take a set, you
Huh?
basically destroy the order, no?
But it will have a naturally coming order, right? Suppose you choose one element from the here, one from another, and they will have naturally coming ordering, right? Whether one will be lesser or other will be greater.
I mean, that's the natural order will be same, but it's not necessary that the order we impose always has the natural order.
Okay.
So, okay, so I have just done a few examples. So I think for the first part, we have that 2 to the power n minus 1 will work. So if you have even number set, say n is even, and you want to
Hmm.
find out the number of subsets with even cardinality,
Hmm.
then 2 to the power n minus 1 will suffice.
Okay.
So the
So
first part.
okay, so n should be even, then it is 2 to the power n minus 1.
Wow.
Okay. And then what we need to do, we need to order them as well, right?
Yes. So that's the factorial.
Yes, that is factorial one. So you are saying ax will be summation n greater than equals 0, and n should be even, now.
N is even.
Yes. 2 divides n. Then what? You are saying
Then
coefficient is 2 to the power n
n
minus 1.
minus 1.
Then
Yes.
you are arranging, then you are n factorial, right?
Yes, n factorial.
Giving them order. Then x to the power n.
Excuse me, one second. It's not
Yes.
n factorial, but to the power n minus 1 factorial, because sorry, no, you can't say that n factorial. I don't think it will work.
Hmm?
So we are choosing n as the number of elements in each set.
Yes.
But how do I say that each of the set contains? Okay.
What is the problem? Hmm?
So uh, one second.
We have n cards, then them arranging them is in n factorial ways, no?
Yes, we that's for if you know that you have n cards. Once you have taken the subset, how do you know that you have n cards?
Yeah, that's correct. Then for each subset we need to do,
Yes.
but that will be slightly lengthy calculation. So if we first do ordering, then we know we have n factorial, then we choose the subset, then we
Then
know
you
2 to
have
the
to
power.
then you have to change from subset to intervals, no?
Hmm?
If you
Yes,
have
subset. Yeah,
uh, then you it
not
will
necessarily interval, because to subset it is fine, because how to explain you? Okay, suppose you have this thing now. Suppose you have some cards, let's say these are cards, some 4 cards, and you give them ordering in this way, let's say. So let's I choose a subset. One element is this, one element this. But then these two have a natural ordering coming. I'm giving them order as a like this. This is A, B, C, D. So A is less than D. This is the ordering I'm giving them.
yes,
Whether I choose,
this is this will always work if you maintain the natural orders increasing or decreasing. But if you have any random permutation, then can you say that?
what random permutation you want to say? Like, can you say again? Can you give
Uh,
some example where this will not work? Like first choosing,
okay,
giving
you
order.
so for so just for my sanity, can you give an example of what you mean? Okay, say
Hmm?
for 1, 2, 3, 4. Say
Hmm?
1, 2, 3, 4. Say we have 1, 2, 3, 4.
Hmm?
You are saying that we first order it and then take subset.
Right.
So say I have the order 3, 1, 4, 2.
3, 1, 4, 2 is okay. 3 less than 1, 4 less than 2. Right. Hmm?
Then you're saying that you take subsets of or you just choose whatever you want, right?
Yes.
So 4 choose say 2 or 3.
2 or 4 choose 4 and 2. You are choosing in a subset?
So, no, I'm asking, do you choose in so okay, how do so you choose any two numbers from there? You can choose.
Yes. Any choose number. Any 2 numbers you choose.
Okay. So okay. So say for 3 and 2 you choose. So you have 3 and 2, and you are saying that this is the
This is
same.
a natural order coming. 3
Yes.
less than 2.
Uh, uh, and if you had chosen 3, 4, 2,
3, 4, 2. So you have this natural order coming.
this is the order is not working here, no?
Why?
Uh, I mean, this has corresponding to it exactly one natural order. What about the other ones?
Other orders will give you another. If you are giving other orders here, that will give other orders here as well.
Okay. Okay. Yes, I get it now. So for each order, you are taking. Okay. 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 I get it now.
Okay, is it clear?
Yes.
So now let's do it. So first you are choosing. First you are. So I guess my idea is correct. So what I am doing. So an is the number of ways to order. So let me write. En is number of ways to order even number of cards. Even number of cards. Then what is an? An is n factorial if 2 divides n and 0 otherwise. Right?
Yes.
So now, so we have given order to this set. So we are choosing this AX. AX is summation an x to the power n, which is summation x to the power n greater than 0 and 2 divides n. So that is basically n greater than equals 2 and 2 divides n x to the power n, which is what? This is what?
Huh?
This is what?
Do you have to have n greater than equal to 2?
Yes. Otherwise it is 0, na?
Yes, 0 is fine.
When
No.
x to the power 0, then coefficient is 0. So that will be 0 basically.
When x to the power is 0, then coefficient is 1. No?
Why it is 1?
So because
A
0
naught is 0. Na? If 2 divides n, then it is n factorial. Otherwise it is 0.
yes, 2 divides 0.
Uh, so an is number of ways to order even number of cards. An is number of ways to order
You
even
order
number
no
of.
card.
If you have no card, then you are saying,
Only one way to do it.
this is a trivial case. Okay. So I should write one for that. If you have no card, then you are saying, okay. If you have no card, then you are saying there is only one way to order, basically no order. So, okay, let's write n greater than 0 only. So what is this thing?
Huh. Even numbers of factorials.
What is this? 1 plus x square plus x to the power 4 plus something, something, something.
Oh, okay. So,
Tell me. Right? Is it clear?
yeah, hello?
Yeah. Am I
Yeah,
audible?
yeah. Yes, yes, yes.
Okay. So this should be clear, na?
Yes.
Now what we want to do?
This is after you have ordered. Can you
So we have,
go back up to the question list?
yes. So we have to give it to subset and then have to order. I first order them. Then we will give it to subsets. Then we want to order the cards within each subgroup. Okay. Finally, we want to order this subgroup into a line. Okay. Now we want to order subgroup in a line.
That is
Okay.
again factorial of the whole thing.
Okay. Then the subgroup. Okay. Okay. What we want to do? We want to order the subgroup like we want to order this subgroup into a line. Okay. So how we will do this?
We have yet to do the subset part.
Yes.
So when choose,
So suppose we have a subset of n cardinality. So we want to order what we want to do now.
we have yet to take the subset, no, even subset. You have ordered it.
We have done in opposite way. So
You
okay,
have done the
so
ordering first. Now you have to take the subset of it.
yes.
So
So
wait a second. One second. There is a is there any problem here? Because yeah, you have already assumed that it has even number of cards, and so you have taken all the coefficients with say uh 3 cards or so, so is 0.
yes.
Now you want to take the subset. So does it matter?
Why does it? What matters? I didn't get.
So does it matter if I order it on n things and then take even subset
Yes.
versus ordering it on on the assumption that we already have even number of cards and then take we take any subset?
Okay. Okay. What you are saying, I get it. So what is this meaning? We want to do this composition A B X. So this means first we will apply B, then we will apply A. So first we had to determine B. What is so first we need to say that when we are dividing them into subset, right?
Yes.
And then we are applying A. Then we are ordering them.
In a line again with the C
Yes.
outer function.
Yes. So what we have done?
We have ordered the even number of cards on the assumption that we already have even numbers.
So basically we have ordered them into line basically, right?
Yes.
An element set into line. So we have determined this A. So we have to determine this B, right?
Yes. So
So
that
what
is
is
again to the power n minus 1 if you have to, if you just take what we had done earlier. No?
yes. So you are saying this we have to the power n minus 1 ways to choose this even subsets, and then we have to order them as well, no?
Yes, that so we the even subsets is fine, no, for ordering.
Wait a second. What is the question? Split them into non-empty subsets so that each have an even number of cards. Then we want to order the cards within each subgroup, and we want. So we need to do two ordering. Na? First, we need to ordering within the subgroup, and then we need to ordering them at these subgroups.
So consider the outer function C. We are not looking at that yet, no. We are currently B is we are we are to use B as the
Choosing
subset
a
taking, choosing a subset,
subset and
even
giving it a
subset.
order, and giving it order.
A is
This
giving it order and B, yes,
no, A is giving order to all subgroups. A is giving order to all subgroups.
A is giving order to all subgroups.
Yes, we have set of subgroups.
Okay.
Then we are giving order to it. This is A. This is in the
So can you one second.
so this is in the definition of composition.
Can you take it up a bit where you wrote A? No, just where you wrote A. Ways to order. You have wrote A in as number of ways to order even number of cards, not subgroups.
I should write even number of subgroups. Yes, this way. You are correct. Now it is fine, right?
So one second. Can you go can you go back up to the question? Is it that we have to do it for all the cards? So say I have done the partitionings into even cards subsets. So when I take the finally want to order these subgroups into a line. Okay.
Yes, this is the thing. So we have to choose a subset and give it to order. So what is
So
BNX?
one thing, notice that when you are doing the subgroups, it is not necessary that they may be even.
It is not necessary that
The subgroups number of subgroups may not be even. You can't use that.
yes. So we should not use this, right?
So that was correct for the second step. No? Just make it
That is
Bn.
correct for cards, but not for subgroups.
Yes, just
So
instead of erasing, we could have just done written it as Bn. No,
just this is clearly, I should write it here. So this is 1 upon 1 minus x, na?
squared. No,
Summation y
it's
square,
squared.
y
Wasn't it
square.
squared before?
Before is squared, but I changed the right
Okay, okay,
thing.
okay, okay.
Yes. Now I need to determine this bx
So
inside
BA,
function.
so the BX is so then you should have BA, C of X inside B of X. No,
Hmm?
do you want to do both the
This
steps in BX?
yes, these steps. Bx is basically choosing a subset and giving it an order. Ax is giving an order to set of subsets basically. So I have given the order of set of subsets. This is in this way, right? An
So
is
so
n
why
factor.
couldn't we use what we had done before in another composition inside of it? So what I'm saying is the previous n, if you recollect.
Huh?
So if I say the previous n that was before
Hmm?
erasing it, so
Hmm?
could we use it as bn here, and then inside of bn we use a n choose even number of subsets.
Okay. So you are saying first we need to choose even number of subsets. So what is that? You are saying that is 2 to the power
That
n
is
minus 1.
Cn. Yes. So if you have it as Cn, then B of Cn, A of B of Cn.
Okay. 2 to the power n minus 1. And then you are saying what?
Then when you have this, then you we just do the Bn. So then Bn is basically what we just did before changing it to the subgroups. So so we should write A of B of X. Sorry, A of B of C of X. No, C of X being the to the power n minus choice.
So what is the definition of Cn here? Number of ways to partition n to no blocks in A structure in each block and build B structure. Okay, fine, fine. So what you are saying? You are saying that okay. Structure. Uh,
No, we have to do it in the single step. I think you can't use CN separately.
this is by definition. Yeah, sorry. So we don't need to choose subset. On subset, this comes by naturally by definition. This is the definition of composition, right? So we just Bn is this thing. Okay. So what is An? What I write above? Ax I write. So Bn is equals to number of ways ways to order even number of cards. Then this is already I write 2 divides n, and this is 0 otherwise. So Bx will be summation n greater than equals 0 Bn x to the power n by n factorial. This is sorry, what is this thing? So this thing is summation n greater than equals 0 to 2 divides n x to the power what thing n. So this is 1 upon 1 minus x square. So we have both things. So what is composition says? So if you still didn't get what is the composition in this EGF, recall that. So an is number of ways to put structure on A, structure A on N. Bn is number of ways to put structure B on N, and Cn is number of ways to partition N to non-empty blocks, means non-empty subsets, build A structure on each block, means A structure means give order to each build A structure on each block, means giving order to each block, and B structure on set of blocks. B structure is also giving ordering on set of blocks. So then Cx is equals to product of Ax is into Bx, right? This is the definition.
Composition.
So we yes, so composition. Then Cx is equals to B of Ax. This is just to coming by definition. We don't need to subset. Is it clear? This is in definition. Number of ways to put ways to partition N to non-empty blocks and build A structure on each block and B structure on set of block. So this is just coming by definition. So we don't need to put it into blocks basically. So then, so Gx is equals to A Bx. So this is, what is Bx? A of what? Bx is what? 1 upon 1 minus x square. Maybe that's why we are getting first problem also stucking at the first problem. We are using this composition rule incorrectly at that point. Then this is Ax. Ax is what? Ax 1 upon 1 minus. Yes. 1 by 1 minus 1 by 1 minus x square. So 1 by 1 minus x square minus 1. So this is 1 by minus x. So we are getting minus 1 by x square. Why this is somewhat incorrect. Why we are getting incorrect? Let me check. I guess he have provided a solution. So, wait a second. Huh?
Okay.
So Ax is fine and Bx, he is considering not considering zero case. So he is considering only n strictly greater than 0, means n bigger than equals to 2. He is considering this case only. Then this will be, you take x square common out. He is not taking trivial case. What initially I was also not taking. So x square 1 plus x square, so on, so on, so on. That will be x square by 1 minus x square. So this is the thing. So then what we are getting? This thing. Then he just doing things for the computation. Minus 2x square by 1 upon bx is 1 minus x square by 1 minus b square. So 1 upon 1 minus x square by 1 minus x square. So this is 1 minus 2x square by 1 minus x square. So this is what? This is, so now we have to compute it. This is equals 1 minus x square into 1 minus 2x square का inverse. So now just open this thing. 1 minus x square into 1 plus 2x square plus 2x square का whole square plus 2x square का whole cube plus so on, so on, so on, so on. So now what we need to find out? We have to find out explicit formula for GN. We can do this. This is the required formula, right? Okay, for GN we need to find out. So GN, so the coefficient GN of, so this is GX, our required thing, B of AX. What we need to find out? Find an explicit formula for the number of ways GN we can do this. Okay. So we need to find x to the power n into n factorial by GX. By GX into GX is equals to GN X. So we need to find nth coefficient. So what is the nth coefficient of this thing? So find out nth coefficient. What is the nth coefficient of this thing? So we need to do it, right? So what will be this thing? This will be 1 plus, so there will be two summations, right? 1 plus, when one series is getting multiplied with this thing, so this will be 2x square की power m. M is running from summation, m is running from where? 1 to infinity, plus minus x square into summation 1 plus 2x square 1 plus summation m equals to 1 to infinity 2x square की power 10. So this thing, so we have to find out, so what is GNX? So this is 0 if n is odd, because we will not get any odd power, and when n is even, what we will get coefficient? So this will be,
The coefficient I think is
2 to the power m plus, sorry, minus what? 2 to the power m minus 1, na? I guess correct. Am I correct? From here, its power will be, when m minus 1 to m minus 2, then x square will multiply, the power will become 2m, right? So, right, 2m minus 2m minus 1. Right? So, is it correct? Abhishek?
1 second.
Where n equals to 2m.
So for n is equal to
2m.
4, we have 2. Yes, so 2, 1, 4, 2. Yes, yes, okay,
Yes.
that's correct.
Yes, because 2 to the power m is here, from 2 to the power m minus 1 is from here. on first for first one 2 to the power m, from second one 2 to the power m. So yeah, this is correct. Okay. So is it clear or any doubt? Now you can ask.
Can you scroll up? Let me
Yes.
see again.
You want to go on to problem? This problem? Yeah, this is the problem.
So I guess the problem was that in the first line when they said we want to split the set into non-empty subsets so that each
Hmm.
of them contains an even number.
Hmm.
So the so this step so the subset choosing step is implied by the exponential generating functions composition. Was
Yes.
that the problem?
Yes.
So
This is just implied.
so what happened to the even number? So do we just obtain that from the ordering because we have cancelled out the uh, odds?
What is the of the even?
So here we had to choose even number of cards. So this constraint was applied by us using 0 for all the odds in the ordering step.
Hmm.
So I'm asking, is that the reason? Am I correct in saying that?
I didn't get still what you are saying. Can you say again?
So each of them contains an even number of cards,
Hmm.
non-empty subsets, so that each of
Hmm.
them contains an even number of cards. So
Right.
this constraint was applied in the ordering step when we
Yes.
put 0, right?
Yes. Yes.
Okay, okay,
That's correct.
okay.
So now it is clear, na?
Yes.
Okay. Let's go to another problem. Uh, a football coach has n players. In players to work with a practice. First, he splits them into two groups and asks the member of each group to form a line. Form a line. Then he asks each member of the first group to take an orange, comma, orange, orange t-shirt, comma, white t-shirt or blue t-shirt, comma, blue t-shirt. T-shirt. Members of the other group keep their red T-shirt. Group keep their red T-shirt. Red T-shirt. In how many ways can all this happen for n? Can all this happen for n?
Are the groups non-empty?
Wait a second. I should read the question. I don't know. So, a football coach has n players to work with a practice. First, he splits them into two groups and asks the member of each group to form a line. Then he asks each member of the first group to take an orange T-shirt, white T-shirt, or blue T-shirt. Member of the other group keep their red T-shirt. In how many ways can all this happen? Okay, so as per the question, the group should be non-empty because otherwise,
Yes.
what? Yeah.
This is basically taking subset. So n choose 2 from n ranging from 1 to, I suppose. No, sorry. I said wrong. N choose k, k ranging from 1 to n minus 1.
Okay. Then.
So these are the coefficients.
Okay.
So for each of the term in the
So what do you want to use? Okay, let's start with this. What do you want to use? Ordinary generating function or exponential generating function?
exponential generating functions, because we are dealing with sets.
Okay. We are dealing with sets. That's correct. Then what? You want to use product or composition? Something?
Do we need to use two functions? I think we can do it in one, no?
I feel that doing with two is easy because we have two groups. On one group, one function, on other group, another function. Then it's easy.
So in the question with the second group, we basically do nothing.
In the question?
In the second group, we don't do anything. So do we need to consider that?
Yes, we need to consider them, right? Each person wear red T-shirt, so each person have no choices. Only one choices, right?
When what I am asking, I suppose, is as in if you choose the first group, that is enough to know the second group, no?
That is enough to know second group, right?
So do we need to explicitly consider two functions? That is what I'm asking.
Look, the red T-shirt. How many ways can all this happen? I guess yes, because in second group nothing is happening. They just wear red T-shirt and nothing more, right? But we need to find out. Football coaches and players to work with in practice. First, he split them into two groups and ask the member of each group to form a line. Each group to form a line. अच्छा line भी तो बन रहा है. We have to arrange them, right? We have to consider second as well. Each group is arranging in a line.
Okay, yes. So both of them form a single line, no?
No. Each group to form a line. First group form a line, second group form a line. Both are different. First we are dividing in a group, then we are forming a line of each group.
Okay. Oh, okay. So in the
Yes.
second group, so in the second group, when we form a line,
Yes.
so there is actually only one line, no?
There is only one line for this line is a choice now for.
Is there a choice?
Yes. If there are k members, then k factorial choices.
But they're all wearing red t-shirts.
Yes, they are all wearing red T-shirt, but the men
How
are
can you
different.
distinguish them?
Men are distinguishable, right? You and me in a line can be distinguishable. Your name is Abhishek, my name is Prakash.
Yes, I suppose if you consider, yeah.
Yes.
If they were fruits, I suppose.
Okay. They are players, so they are distinguishable.
Yeah.
So, can you say something now? I hope the question is clear now, what he's saying.
Yes.
So now tell me,
So
what is
the
AX
choices
and
are
what?
independent, so you can use product.
Okay. So what is AX and what is BX?
Am I right in saying the choices are independent?
Hmm?
Am I right in saying the choices are independent?
Yes, they are independent. They are arranging only on second one, only one step is going. We are
Yes,
arranging
yes.
them
So
in a.
yeah, there. Yes, sure.
So tell me,
Okay, so in the first group we are choosing okay, as we first the two groups.
AX is whatever
Okay,
going on in first group. For me, AX is a first group. So tell me what is the AN for this thing?
okay.
Summation AN x to the power n greater
So
than 0.
so AN is the term n choose k, where k is from 1 to n minus 1.
So should I use ordinary one or exponential one?
Or exponential, because we are dealing with sets now.
Yeah. Then
The sequence an is n choose. Okay, so if you have a, I suppose it would be better to write a k, or what is the total number of people?
n people, let's say.
So n choose k.
AN is n choose k.
So from k ranging from 1 to n minus 1.
Hmm.
So in terms of power series, you should have so yes, that's correct.
What's correct?
So you have to restrict k to 1 to n minus 1.
What is AN basically for? AX is summation AN to the power AN into x to the power n by n factorial. What is AN?
I mean, if you change n is basically the total number of people. So if you say an, then I have to use some other symbol for n.
AN is not only number of people, then you are arranging them into line as well.
Then so we
And
should write
also
ak,
giving
no?
them, since you are in first group, also giving them choice for 3 t-shirt. He can wear red t-shirt, he can wear orange t-shirt, white t-shirt, or blue t-shirt. So 3 choices of t-shirt as well. So everything is there for group A. So now tell me, this is AX is for first group and BX is for second group. So on one group, the structure is A structure, where you are arranging them, where you are arranging them into line and giving them t-shirts, all these things. And B group, there is
Okay,
only one
so
step.
we have to, okay. B group is just the lines, right? Okay. So you have three multiplication, three choices for each member.
Hmm.
Okay.
So just recall the product rule for you, because you are again doing same mistake. So let's recall the product rule for you again. So AN is number of ways to put combinatorial structure A on this n cardinality set. In this case, your AN is number of way to put this structure of means arranging them into line, then giving them t-shirt choice on this, whatever the group one is. Group one has any n number of element, let's say, and BN is number of ways to put combinatorial structure B on n. Here what is B structure? B structure is arranging them into line, and they are only wearing one t-shirt, so there is no choices on them. Then CN, which is total number of ways to build a structure on some subset on any subset. First, total number of ways to first choose a subset. First, choose a subset. Choose a subset S and give it A structure and B structure on its complement. I hope now it is clear to you what mistake you are doing in initially saying, because you are choosing n choose k, n choose k, n choose k again and again. You are again choosing the k subset for group 1. I hope now it is clear. Is it clear? Abhishek, are you with me? You don't need to do that. You just need to do for an, just need to do for bn. This subset one, how you are choosing any subset means how you are choosing this k element. This is coming natural.
Okay.
By the definition of product. Are you getting or not?
Okay. Okay. Yes. Yes.
So now tell me what is.
So
What is
AX is basically the constant series. So no, 3n. So what?
3
3 to
3n?
the power n.
Why 3 to the power n?
No, AK is 3 times n.
What you are saying? You have n peoples, so you are
Yes.
arranging them into lines. So that is n factorial ways.
Are we
Right?
arranging in the A step?
Yes, A step is the first group and B step is the second group for me. Operation we are doing in a first group, that is a step for me. Operation we are doing in the second group, that is a B step for me.
Okay. Oh, okay. Oh,
And
oh,
n factorial. Then you are giving them a T-shirt as well. Either
yes.
either one can wear blue, one can wear red, or one can wear white. So each has 3 choices. So 3 to
3
the
to the
power n
power
choices.
n. Yes.
Yes. So an is n factorial into 3 to the power n. What is bx?
So that's just in factorial or in complement or whatever. So that's uh,
Bn is n factorial, right?
should
Because
we
we are
use
just.
n in both of them? Should we use the
Yes, this is in the definition. Number of ways to put combinatorial structure on A on n. Number of ways to put
complement of?
Why? This is naturally coming from definition. Complement is its definition. A
Okay.
structure and B structure on its complement. Is it clear?
But now it's a bit confusing because you have n people and you have so say you have n people and by the definition you have taken some subset of it and then handed them some
Yes.
t-shirts and
So I
ordered
have
them.
n peoples and I am arranging them into subset. That is coming from this product rule. Na? So this Cn is basically, I am finding out the Cn. Na? I need to find out the Cn. So total number of ways to first choose a subset. So which we need to choose groups S. Basically, I am choosing group A, which is S. Then give it to A structure. I am giving it a structure means I am arranging them into line and giving them each one 3 possible choices of T-shirt. And
So my question would be, how do you avoid choosing the people from AN?
How do you avoid the choosing people from?
AN. So the people in the other group, if you
Huh?
choose from N on again, then so
No. You are confusing with this AN and BN. This is just by definition. AN is you are giving A structure. This is a group 1. This is a group 2. And then by C, I need to compute this CN. So for this CN, what I need is total number of ways to first choose a subset. That is what I need to do. I choose a group, which is a group 1. S is my group 1 and give it a structure. So I need to arrange them into line and give it to t-shirt, and B structure on its complement, and complement I am arranging them in a line and giving them red t-shirt. So this is this what I need to find out.
So the complement is coming by definition also.
Yes, by definition.
Okay, so okay.
So then CX is AX into BX. AX into BX. So what is AX? AX is n factorial into 3 to the power n, x to the power n by n factorial, and BX is what? N factorial x to the power n. So what is this? Summation n bigger than equals to 0, 3 to the power n x to the power n into summation x to the power n. डिनोमिनेटर में कुछ भी नहीं है. So what we need to find out? We need to find out how many ways can all this happen for n. So we need to find out x to the power n by coefficient of x to the power n by n factorial in Cx. Right? That is what we need to find out. So what is that? What is the coefficient of x to the power n into n factorial? So this is what? Multiply them. What is this? Summation. I should write here m bigger than equals to 0. 3 to the power x to the power n plus m. N comma m bigger than equals to 0. Right? This is the thing. Coefficient of x to the power n by n factorial. So what is the coefficient of x to the power n by n factorial? So this will be.
Where is m? What is
Where
m?
is?
What is m here? M?
This thing.
So wasn't
Second.
it just before n? Weren't we
Both
just discussing about that the order would be naturally imposed and it would remain in?
This is just multiply for multiplication. Like otherwise, you will feel that it is always getting 2n. But I so that you didn't get confused. That's why I write m, because otherwise you will feed here x to the power n, here x to the power n. That will be x to the power 2n. Always even term will be occur. So that's why I write m, because this will be of the form 1 plus x square of this form, right? And this will of the form 3 to the power n x to the power n. That will be 1 plus 3x plus 3 square x square of this form, right? So what? So like here of the terms of the form 1 plus x plus 3x is this kind of term will occur. That's why I write this thing. Otherwise, you can write n as well if you are not getting confused. But then it will be x to the power 2n. You will feel that you will say that it is x to the power 2n. That's why I'm not writing in terms of n only.
So how do you choose m?
How do you
Choose m?
choose?
M.
M is same thing as n basically. These are indices. This is just a multiplication of power series.
So m is always same as n.
M is always same as n. These are both things are power series. This is just a multiplication of power series. So m is just indices of power series. N is also indices of power series. You know multiplication of power series.
Yes. Okay. Yeah. I got confused. Yes, sir.
So what is the thing? So what is the coefficient? N factorial into what? Summation. Three to the power. What?
N.
N minus k. K is equals to 0 to n. This is the thing, right? Correct?
Yes, yes.
Yes. I hope it is clear. If not, you can ask me. Because 3 to the power n minus k is coefficient because k
Yes.
will be from second one. Yes.
Okay.
Is it clear?
Yes, yes.
Now this problem should be also clear, which we are initially stucking. The same mistake we are doing at that point. We are using composition, then what is this problem? This one is, no? Then he choose a possibly empty subset of the newly formed units for night duty. The officer splits the line at several places, forming smaller units. Acha. Then he choose a possibly empty subset of a newly formed units for night duty. Okay, let's discuss this next time. Or I will write a solution on upload it on PDF. Okay.
Okay.
Okay. So with this, stop here. Go to Zoom. Stop recording.